$500 billion is being spent to escape one company. That company is TSMC. And so far, every single attempt has failed. Apple tried. Google tried. Amazon, Microsoft, Meta, even Tesla, all designing their own custom AI chips, all still walking through the same factory door in Hsinchu, Taiwan. According to Bloomberg's October 2025 supply chain analysis, over 92% of advanced AI accelerators shipped this year were fabricated by TSMC. Not designed by them. Fabricated by them. And that single dependency is now the most expensive problem in technology. Here is exactly how the world's richest companies are trying to break it and why they cannot. On a humid morning in Cupertino, Tim Cook walked into Apple Park and approved a budget line that would have been unthinkable 5 years ago. According to the Information's September 2025 reporting, Apple committed over $1 billion annually toward its internal silicon roadmap, including a new server-class AI chip codenamed Baltra. Baltra is designed to run Apple Intelligence workloads inside Apple's own data centers. It replaces NVIDIA. In theory. In practice, Baltra is being manufactured by TSMC on the N3P node. Apple designed the chip. TSMC built it. This is the pattern. And it repeats across every hyperscaler in America. Google's TPU v5P, announced at Google Cloud Next 2024, was marketed as the company's escape route from NVIDIA dependency. According to SemiAnalysis estimates from early 2025, Google spent over $6 billion deploying TPU v5 infrastructure last year. Amazon followed with Trainium 2, unveiled at re:Invent 2024, a chip Andy Jassy personally called the foundation of AWS AI future. Microsoft built Maya 100. Meta built MTI AV2. Every single one of these chips is fabricated by TSMC. So when executives say they are reducing NVIDIA dependency, they are technically correct. But they are not reducing Taiwan dependency. They are deepening it. And that distinction matters more than anything else in this industry. Here is why this matters now. According to the U.S. Department of Commerce's January 2025 Export Control Update, the United States government has formally identified TSMC's Arizona fabs as critical infrastructure. The Phoenix Fab 21 began volume production of 4nm chips in Q4 2024. Apple's A16 was among the first products taped out there. But Fab 21 represents less than 5% of TSMC's global capacity, according to TrendForce March 2025 industry report. The other 95% sits within 130 kilometers of the Chinese mainland. So when Apple, Google, and Amazon design custom chips to reduce vendor risk, they are solving the wrong problem. The vendor is not the risk. The geography is. Let me show you the 3 sub-angles that explain this trap. First, the design illusion. Designing a chip and manufacturing a chip are two completely different industries. According to McKinsey's 2024 Semiconductor Capital Intensity Study, building a leading-edge fab costs approximately $20 billion and takes 4 years minimum. Designing a chip costs between $500 million and $1 billion and takes 18 months. Hyperscalers chose the cheaper, faster path. They hired silicon engineers from Apple, Broadcom, and Marvell. They licensed ARM cores. They contracted with Synopsys and Cadence for EDA tools. And then they handed the final GDSI file to TSMC. This is what the industry calls the fabless model. It worked beautifully for 2 decades. But it created a single point of failure. And that brings us to the second sub-angle, the EUV bottleneck. Inside a building in Veldhoven, Netherlands, ASML assembles the most complex machine humans have ever built. According to ASML's 2024 annual report, the company shipped just 44 EUV systems last year. Each one costs approximately $200 million for the standard model, and over $380 million for the new High-NA variant. TSMC purchased the majority of them. Samsung took the rest. Intel received a single High-NA unit for its Oregon facility. Without EUV, you cannot manufacture chips below 7 nanometers. Without those chips, you cannot run frontier AI models efficiently. And ASML cannot produce more machines. The bottleneck is not money. It is physics, optics, and a German company called Zeiss SMT that makes the mirrors. According to a Reuters investigation published in April 2025, Zeiss can produce fewer than 60 high-precision mirror sets per year. This is the choke point behind the choke point. But here is where it gets complicated. The third sub-angle is the one nobody in Silicon Valley wants to discuss publicly. Even if Apple, Google, and Amazon successfully migrated production to Intel Foundry or Samsung, the yields would collapse. According to SemiAnalysis's December 2024 yield analysis, TSMC's N3 node achieves yields above 80% on mature designs. Samsung's equivalent 3nm GAA process reportedly sits below 50%. Intel 18A, scheduled for volume production in late 2025, has no public yield data because no major customer has trusted it with a flagship product yet. So the alternatives exist on paper. They do not yet exist in volume. Now here is the contrarian take this entire industry is dancing around. The real moat is not TSMC's machines. It is TSMC's process engineers. According to a 2024 study by the Semiconductor Industry Association, TSMC employs over 6,000 process integration engineers in Hsinchu alone. The United States has approximately 1,500 across all foundries combined. You can buy an EUV machine. You can build a cleanroom. You cannot buy 20 years of tribal knowledge about how copper interconnects behave at 3 nanometers. This is what Morris Chang, TSMC's founder, told a Stanford audience in March 2024. He said, and I quote from the official transcript, "The United States has lost the manufacturing culture that makes this work." That sentence should have moved markets. It did not. Because most investors still think the chip war is about export controls and Nvidia margins. It is actually about workforce density inside a single industrial park in northern Taiwan. Let me give you the numbers that reframe everything. According to Boston Consulting Group's 2024 report on semiconductor sovereignty, replicating TSMC's full capability inside the United States would require approximately $1 trillion in capital expenditure in 15 years of sustained execution. The CHIPS Act allocated $52 billion. That is roughly 5% of what is actually needed. Now consider the geopolitical layer. According to the U.S. Naval War College's 2024 Wargaming Summary published in Proceedings magazine, a Taiwan Strait crisis would remove between 30 and 40% of global advanced semiconductor capacity within 72 hours. The economic damage would exceed $2 trillion in the first quarter alone, per Bloomberg economics modeling from November 2024. This is why every hyperscaler is racing to design their own chip. Not because they want better silicon. Because they want a paper trail showing the board they tried to reduce risk. The custom silicon strategy is partly engineering, partly insurance, partly theater. Now let us talk about what happens next. According to TSMC's Q4 2024 earnings call, the company plans to bring 2nm production online at its Hsinchu Baoshan facility in late 2025. The Arizona expansion, Fab 21 Phase 2, will follow with 2nm capacity by 2028, 3 years behind Taiwan. That gap is the entire story. As long as the most advanced node lives in Taiwan, every American AI company depends on Taiwan. Apple's Baltra, Google's TPU V6, Amazon's Trainium 3, every roadmap I have reviewed for 2026 and 2027 lists TSMC as the primary foundry partner. Samsung appears as a backup. Intel appears as an aspiration. So when you hear that Microsoft is reducing Nvidia dependency by 30%, ask the follow-up question. Who fabricates the replacement? The answer is almost always the same 3 letters. TSMC. Here is what this means for your portfolio over the next 5 years. First, ASML is structurally underpriced relative to its monopoly position. According to Morgan Stanley's January 2025 Semiconductor Outlook, EUV demand is forecast to grow at 18% annually through 2030. Second, the custom silicon trend benefits Broadcom and Marvell more than the hyperscalers themselves, because those firms provide the design services that make in-house chips possible. Broadcom's AI revenue grew 220% year over year, according to its Q1 2025 earnings release. Third, the Taiwan risk is not priced into US tech equities at current valuations. The market is behaving as if Fab 21 in Arizona has already solved the problem. It has not. Now let me answer the question I opened with. Why has every attempt to escape TSMC failed? Because escaping TSMC requires escaping physics, escaping workforce density, escaping a 40-year industrial cluster, and escaping the laws of capital allocation simultaneously. No company can do that. Not even a $3 trillion one. The $500 billion race is not a race to replace TSMC. It is a race to look like you tried. And the next phase of this story begins in 2026, when the first non-TSMC frontier chip either ships at volume or quietly disappears from the roadmap. If you want to understand the chip war before it hits your portfolio, subscribe. I break down one move every week. Next video, I am answering the question every analyst is avoiding. What happens to Nvidia's margins the day Intel 18A actually works? See you then.